Okay, as I mentioned earlier, for living polymerization to be occur, so it must be done without the involvement of water. But generally, in anionic polymerization, termination occurs only by the deliberate introduction of oxygen, carbon dioxide, methanol, or water. So, means that um, general anionic equation, it has to be terminated by using water or other like oxygen, carbon dioxide, and so on. So look at this structure. This is come from, so this is the propagation reaction. Okay, step from propagation, we add with water, uh, um, carbon ion, okay, carbon ion which is negative charge here, together with the positive lithium. Note that the initiating species in this example has been incorporated as an end group of the terminated polymer chain. So this illustrates the role of butyllithium as an initiator rather than a catalyst. Okay, look at the second example, starting with the initiation, which is dissociation and association. So just like a free radical polymerization, initiation also divided into dissociation and association. For dissociation, it involves the form of a butyllithium cation and a negative butyl anion. So look at this butyllithium structure. This structure actually it fall apart to form the positive lithium and the negative butyl and ion. So we call it as the negative butyl and ion. So this lithium structure actually act as a electron donor, or also known as a Lewis base. Lewis base is a nucleophile. So for example, beside lithium, we can replace with a sodium. It is a strong nucleophile initiator. Okay, so the other strong nucleophile initiator is covalent or ionic metal, amide, alkoxide, hydroxide, um, Grignard reagent, and so on. So carbon ion ataupun butyl and ion, it has a negative charge here, which is on the carbon atom. So the butyl and ion will then associate with a monomer molecule. Okay, ini adalah step dissociate. Lepas tu dekat step initiation, which is association, awak salin je balik yang ini structure ni. Salin balik CH3, CH2, CH2 together with the monomer yang kita nak react. Okay, so this is the ethylene monomer. So look at here, the electron donate here, electron at the carbon, negative charge is on a carbon atom here. It donate the electron to carbon atom at the monomer. So we can see that the double bond here will be shifted. So it will become a single bond. So cara dia nak tulis ni, awak salin je balik CH3, CH2, CH2. Yang ni CH2 sampai sini. Then salin balik structure dia. Structure monomer ni yang kat dua last ni. And then dia punya Lewis ni together with the negative charge transfer here. Okay, is transferred here and left the lithium positive charge at the end of butyl and ion structure. Jangan tinggal lithium ni. Kesian pula lithium ni. Jangan tinggal lithium ni. Kena tulis juga dekat belakang ni. So please make sure that you you write down the negative and the positive charge. So this is initiation step. Okay, next is the propagation. So in propagation, the carbon ion now react with another monomer. So ini adalah carbon ion. Each time another monomer is added to the growing chain, a new anion is generated, allowing another monomer to be added. So untuk step propagation, plus dengan ethylene, same method. 1, 2, 3, 4 carbon, 1, 2, 3, 4. Then tambah dengan 2 carbon kat sini daripada ethylene yang tadi. And then tambah dengan 2 carbon yang kat sini. Okay. Same procedure ataupun same reaction which are electron from carbon here is donated to carbon at the monomer. Okay. So it will become a larger molecule or larger polymer here, larger butyl and ion. And then termination, anionic addition polymerization have no formal termination because proton transfer from solvent or other positive species does not occur. So intention termination can occur through the addition of water or alcohol. Another method of termination is by using a chain transfer. Okay, look at the termination step. Tersalin balik yang daripada result from propagation plus dengan water. Senang tengok dekat soalan sama ada dia letak water ke ataupun benda lain macam carbon dioxide ke, oxygen ke, solvent ke. And then the resulted is the polymer with structure. So look at the termination step here. Salin balik daripada propagation. So must be react with water. And then untuk dia punya ni singkatan dia buat ni macam tak habis, singkat sangat. So this is the real structure. Okay. So dekat sini salin je balik CH3, CH2 ada berapa carbon nak bilang 1, 2, 3, 4, 5, 6, 7. Salin balik 1, 2, 3, 4, 5, 6, 7. So make sure that at the end of this structure, which is the terminated polymer chain here, hydrogen akan jadi 3 kat sini. Okay, sebab dia dah leftkan dia punya Lewis space ni. Lewis space ni semua dia dah hilang. Dia dah LiOH dah form as a byproduct here. So make sure awak buat CH3 bukan CH2. Alright. Okay, overall reaction between butyllithium and styrene. So look at here, dia tulis macam C4H9 pun boleh. So C4H9Li will react with styrene monomer. And this is the initiation step. Dia tak tunjuk dekat sini. Step dissociation dengan association. So better for you to show the step for initiation and dissociation of the butyllithium dengan monomer. So this is the association, okay, association between butyllithium and monomer styrene. So the result is negative butyl and ion of polystyrene with positive lithium. Okay, dia salin je C4H9. Lepas tu salin balik structure ni CH2 CH without double bond. Okay, and then Li dekat belakang. So in the propagation step, salin je balik yang ni, dia akan react balik dengan monomer yang sama. Then salin je balik yang ni, jangan ambil Li ni, Li mesti duduk kat belakang. Salin je balik, cuma tak ada double bond je. Okay. Senang sangat. Untuk termination, sama juga, salin balik yang daripada result from propagation and then react with yang kat sini dia guna solvent methanol. Okay, so when react with methanol, sama juga, salin je balik structure ni sebiji-sebiji dengan yang ni, CH2, CH. Okay, tapi yang ni dia CH3 ni dia letak dekat belakang. Okay, sebab dia akan produce byproduct dia mestilah Li dengan OH. CH3 dia akan migrate from here to the carbon atom here. Alright, so the end of the structure is the methane structure. Otherwise, if you want to terminate with water, same procedure, salin je balik, and H sahaja yang akan attack dekat sini. So dia mesti cukup 1, 2, 3, 4. Okay, 4 chain lah. Okay, jangan kurang. Mesti cukup 4. Okay, sebab dia dah tak ada anion ataupun charge kat hujung. So awak kena cukupkan dia punya hydrogen kat sini. Alright, faham eh? Okay, this is example 3, which is polymerization of PMMA. So I want you to make exercise. Okay, please do the exercise on the reaction of butyl lithium with MMA. MMA structure CH2 double bond C CH3 COOCH3. Okay. Right. So what is leaving polymerization? There is no termination by combination in an ionic polymerization. So this is because the growing chain repel each other electrostatically because of their similar charge. In carefully controlled system, it must be conducted in carefully controlled system which is pure reactant and inert solvent. So in the absence of impurities, the carbon ion will still be active and capable of adding another monomer. The chain will remain active indefinitely unless there is inadvertent or deliberate termination or chain transfer. So for leaving polymerization, it is type of an ionic polymerization, but it not undergo a termination reaction. So the chain will remain active unless there is a termination or termination by chain transfer or deliberate termination. What is the consequences of leaving polymerization? It is popular method for synthesize block copolymer, which is styrene butadiene rubber. Using this method, it is possible to synthesize macromolecule compound with control of a wide range of compositional and structural parameters, such as molecular weight and molecular weight distribution, copolymer composition and microstructure, stereochemistry, branching, chain and function. Besides, it is also possible to produce polymer with complex shape, for example with a star, ladder, cyclic comb shape, by employing polyfunctional initiators or terminating monodisperse leaving polymer with polyfunctional linking agent. It is also possible to introduce the specific end group by terminating the leaving polymer with an appropriate agent. Okay, so macam mana kita nak produce this type of complex shape? So kita dekat end group masa terminate tu kita boleh introduce agent lain lah. The utilization of the synthesis of block copolymer or functional ended polymer approaches provide the synthetic polymer chemist with a powerful tool for producing polymer with fascinating architectural features and properties. For example, the formation of styrene butadiene rubber. Okay, there is no termination by combination. Okay, because the growing chain repel each other electrostatically because of similar charge. Alright.